So what I'm doing now is having another look at what is the farce of Einstein physics, and the main thing I will be referring to is the black hole wars, my battle with Stephen Hawking, which is by Susskind, and so I'll first refer you to who this person is. It's Leonard Susskind. It's from Wikipedia. He's a professor of theoretical physics at Stanford University, and he's had his interests in string theory, quantum field theory, quantum statistics, and so forth. He's now been putting on quite a few of his lectures onto the internet. And there he is. So his talk is here, and he's just going to be introduced. So allow this. Right.
And the author not only of the Black Hole War, but also The Cosmic Landscape, another introduction to the far out frontiers of physics and astronomy. He's written many articles on recent developments in science and their meaning. He teaches a popular continuing studies course at Stanford on modern physics, and has won the American Institute of Physics Science Writing Prize for an article explaining black holes in everyday language. His scientific research focuses on particle physics, quantum theory, and the nature of gravity. Small questions, right? But in fact, he is as well known for being a superb explainer of science. And so we have asked him tonight to explain a little bit about his ongoing intellectual battle with Stephen Hawking on the subject of some of the most mysterious objects in the universe, black holes. Ladies and gentlemen, it's a professional privilege for me to introduce Dr. Leonard Susskind.
So, Professor Leonard Susskind has been arguing with Professor Stephen Hawking over black holes, and so this is one of the things coming out of that. He's written a book on it, and he's called it the Black Hole Wars, My Battle with Stephen Hawking. So we'll pick up what he's got to say about that after I point out the direction I'm coming from. So I've had one of the emails by Harry Vicker, who's pointed my attention to this video by him, by Susskind, and this is what Harry Vicker has said to me. I have seen two videos by this Leonard Susskind. He has put out a series of physics lectures. He's got quite a few lectures now on the internet. I was not impressed by the first lecture I saw, and the second one I gave the link to previously is pretty astounding in the way he tries to make something obviously observed sound like it is actually valid laws of physics. And that link he's referring to is this one here. So we'll get back to it. What he's saying about it is pretty astounding in the way he tries to make something obviously absurd sound like it is actually valid laws of physics. Again, take the time to see the video. It's pretty eye-opening. In addition to the silly explanation regarding the black holes, in which it seems there are multiple true realities, he says the universe is a hologram. That is not the direction I want to go into. So it's Harry Vicker has brought my attention to it. There's various of us, and we all start complaining about how modern physics has gone bad. If we go on to this one, it's this is what Harry Vicker has said about a documentary which has come from our group called Einstein is Wrong. The article he's written is called Pioneer Introduction to the Social Revolution in Science, and it's about this video, well, this documentary film called Einstein Wrong, The Miracle Year. It was written by It was produced by David Hilser. It's a documentary that explores an important nascent social movement that is currently ignored by the establishment mainstream media. It documents the aspirations of ordinary people to more completely understand and appreciate the world they live in, but who do not, because of a systematic conspiracy to obscure the truth and censor differences of opinion in scientific research. It's unfortunate to use the word conspiracy, but basically that's what it is. In science journals they try to censor dissent with Einstein, and you've got more chance of being published if you are agreeing with Einstein in some sort of way. And this documentary is trying to point out that Einstein is really wrong. So if we go down, so this is what Harry says: David Hill's film is a first step forward in a revolution of scientific truth that is needed to resolve the mystery of Einstein's relativity. It declares a simple fact that resolves the problems encountered in trying to make sense of Einstein's relativity theory. That solution is that Einstein is wrong. So if you try to make sense of Einstein's relativity, the solution is Einstein is wrong, and that's a valid conclusion to make. Read Einstein's relativity and reach the conclusion that Einstein's wrong, and you will agree with us. You will agree with people like me and Harry and the person who's made this documentary. Einstein wrong, the miracle year. That is the simple answer. Einstein is wrong. So David Hill's documentary film Einstein Wrong is destined to be remembered as a pioneering introduction to the social revolution of science that is underway and gaining momentum. There's a great number of us now. There's a growing number of us deciding Einstein is wrong. So if we go back to we'll go back to this little talk by Susskind. What he's going to say is pretty much nonsense, but I'm only going to pick up on a certain few things. So it's an hour and a half video thing, and it's too long to go into, but basically it's all nonsense, and I'm just going to pick up on just one little thing to emphasise how bad it is. So basically, getting back to the issue, it's Susskind arguing with Hawking over the issue of black holes.
Better? Okay. I can one-up you, Andrew. You're right, I do teach a class for the general public at Stanford. The name of the class, I don't remember the precise real name of the class, but we all call it Quantum Mechanics for Old Farts. Anyway, I am not an astronomer. I've only once in my life looked through an astronomical telescope, so I may disappoint you. I don't have wonderful pictures of this or that galaxy and so forth. What I'm going to tell you about is a big controversy that took place in theoretical physics that had to do with black holes. Now, if you buy my book, and please buy my book, I get about $1.50 for every book you buy. If you buy my book and you open up to the central chapter, you'll find that the absolute central chapter, the center of the book, is called The Battle of Santa Barbara. The Battle of Santa Barbara was a physics conference. A bunch of theoretical physicists got together to battle out one of the central questions, one of the deep questions of theoretical physics. And I didn't know this when I wrote the book, but after I wrote the book, I discovered that one of my friends had taken a picture of the conference, and here it is.
So basically, that is a joke. He's showing supposed to be a joke of the it's supposed to be a picture of their conference, and really it's probably representing all these people who say experts in Einstein's relativity, and they're all arguing over black holes. They're all probably having different opinions about black holes. They're not agreeing on things, and they're arguing. So I think I'll put the sound up a bit. I think it's a bit quiet. So has it gone there? Oh, just quite loud anyway. So go back to it.
Let's see if I can remember who's who here. Here's Stephen Hawking over there. That's me. John Wheeler is over here.
So he's just continuing with the joke at the moment.
That's a joke, but maybe most of you get it. In any case, the Black Hole War was not really a war between people. It was certainly not a war between armies of people. It was a war between concepts. If you could photograph ghosts, this photograph would have a ghost of Einstein hovering over the whole thing. And the ghost of Einstein would be weeping. He would be weeping because the battle was between two of his children, two of his favorite children. It was a battle between the principles of general relativity.
So it's general relativity here and quantum mechanics here. It's supposed to be a battle between the two theories because it doesn't really, they don't really agree. You can't really combine them properly together. And it's, of course, Einstein has created this mess. Trace it back to Einstein. Einstein sort of created all this problem.
The so-called equivalence principle on the one hand, and on the other hand, quantum mechanics. These two theories clashed with each other from the very, very beginning. They were like angry enemies that simply couldn't reconcile each other. But the real battle broke out over the properties of black holes. Now, again, this is not a real photograph of a black hole. I wish it were. This is an artist's rendition. I suspect the background is quite real, but the black hole at the center is an artist's picture, but it's actually quite accurate. The boundary of the black hole, of course, is called the horizon. You can't see anything from inside the black hole. And, of course, all of these rings and distortions around the black hole are due to the fact that black holes bend light. So this is a picture of a black hole. This is a picture of an imaginary astronomical black hole. But the debate was not really over the properties of real astronomical black holes. It was over the principles of quantum mechanics, gravity, and how they relate to black holes.
So it's argument over theories, really. So nothing really to complain about much up to here, really. It was an argument about theory.
Principle is that information is never lost. Information comes in bits. I'll explain to you what that means. What does it mean for information to come in bits? You all know that your computer is full of bits. Well, here's a piece of information. I doubt that it's true. Maybe it is true. But it is a piece of information. King Canute had warts on his chin. Everybody will agree, either true or false, this is a piece of information. But how do you quantify the amount of information that's in this sentence? So let me quantify it for you. To quantify a bunch of information, what we do is reduce it to bits. Reducing it to bits is the same thing as reducing it to Morse code. Here's Morse code, but King Canute had warts on his chin. And it consists of a bunch of dots and dashes. Information comes in bits. Bits are the same as dots and dashes. King Canute had warts on his chin is a 65-bit sentence, a 65-bit message, and that's what the quantity of information means. The number of bits or the number of dots and dashes that it takes to express a given thought, idea, message. That's how much information is in it. Now, as I said, one of the deepest principles...
I don't really want to get into an argument about things like that, because you can have other sorts of information other than bits. You could have analog information, but I don't want to get into an argument about that. I'm just going to let that go.
...of information, or of physics in general, is that information is never, ever lost. If you have some information in your computer, you can erase it. If you couldn't erase the information in your computer, it would get overloaded. But really, in fact, that information is not lost. What happens to it is it's ejected out of the computer in a little bit of heat. It is not lost information, it is scrambled information. A little bit of something gets ejected out into the atmosphere, scrambled around, hit by molecules and so forth. For all practical purposes, it's lost.
Yeah, in a sense, the information is getting scrambled.
But if you could examine every molecule in the room, every molecule of the computer, you would find that bit lurking someplace.
Which would probably be practically impossible. Be extremely difficult to do something like that.
So bits of information are never lost. As I said, that is one of the very, very deepest principles of physics. It goes way back, it actually goes back past quantum mechanics to classical mechanics, and it is sacrosanct, or always was sacrosanct. However, in 1976, Stephen Hawking put forward an idea that seemed to undermine that basic principle. The idea had to do with black holes. Stephen was a great expert on black holes. You are not great experts on black holes. I'm only a medium expert on black holes, but I have my way of thinking of them.
He says he's only a medium expert on black holes. That's kind of ridiculous, isn't it, really? He's talking about black holes. He's supposed to be an authoritative figure on talking about black holes, and now he's trying to wiggle out of that.
And I'm going to share with you my way of thinking about them. Imagine an...
So, I don't want to go into the information issue, but that's where he's coming from, and now he's going to present what is really thought experiment of a type, where he's trying to simplify things as these fish in water, and this is sort of like a vortex or a whirlpool or something, and that's supposed to be representing sort of similar to a black hole. So you've got fish and this whirlpool, which is going to represent a black hole, and the fish swimming in the sea, and the only ways they can communicate is by sound, and the sound has limiting speed on it. So this is going to be analogous to what is supposed to be happening with a black hole, and it's all a thought experiment he's coming up with. This is basically what I want to criticise, his thought experiment.
And it's not a very deep lake, a meter deep, 1 meter deep, and in that lake lives fish. The fish communicate with each other. How do they communicate with each other? By sound. They're blind fish, they can't see, they communicate each other only by sound, and there's a rule. Whether it's a law of physics or a law of fish or a law of, or a legalistic law, it doesn't matter to us very much, but the rule is no fish is allowed to swim faster than the speed of sound in the water. That means he's not allowed to swim faster through the water than the speed of sound. It could be a law of nature, as I said, or it could just be a law of fish. Well, this lake...
And that's basically what I want to criticise, what he's just said then. So, he's kind of obviously trying to compare this speed of sound thing to how we deal with the speed of light. So I want to go to what he's just said. I've written it up here. That is where the most significant bit I'm going to refer to is when he's talking in this area. So roughly what he's saying is there's a rule, whether it is a law of physics or a law of fish or a legalistic rule does not matter to us very much, but the rule is that no fish is allowed to swim faster than the speed of sound in the water. Of course, this is supposed to be an analogy to us with the restrictions and special relativity that we can't go faster than the speed of light. And what he's doing, and the way he bluffs it off as it doesn't matter very much whether it is law of physics or law of us as people, or 3 legalistic law. So the way he's trying to deal with the speed of sound is the same way his special relativity deals with the speed of light. So this restriction on the form of special relativity, he's telling you it doesn't matter whether it's a law of physics, a law created by us, or a legalistic law. He's bluffing us. He's absolute bluff. So Einstein's second postulate about the speed of light has gone under numerous revisions as to what it's supposed to mean, and now he tries to bluff it off as does not matter very much what it means. What a cheek. The whole of modern physics has been built on a farce. It's a farce. It does matter. This restriction of the speed of light, it does matter. Is it a law of physics? Is it a law just invented by us? Or is it a legalistic law? What sort of law is it supposed to be? And it is under this second postulate has gone under numerous revisions, and now he's trying to pretend to us it doesn't matter. You could carry it on in the rest of the talk and try to put aside that issue of what he's just said, but it is a complete and utter bluff. Just nonsense, just there and then. So we now go to my videos. Right, this is one of my significant ones. It's having, in this video, having a variable speed of light is hiding variable speed of light by math manipulation in relativity. And so when we go to the maths, what they do is they form this sort of triangle where you get a hypotenuse of the triangle is distance ct, this distance bt, and this distance is ct0. That's pointed out in there, and then they have that is equal to that. So if we just went the normal way of that sort of triangle as dealt with by Newtonian physics, it would be speed along there would be c, speed along there would be v, the speed along there would be c times the square root of that. So if you then multiplied all those sides by t, you would get those distances, that distance ct, that distance vt, and that distance c times the square root of that times t. All those sides would have the same time on them. But the way they want to deal with it, they want to have that time along there as t, that time along there as t, and that time along there as t0, a different time to these. And then they create this thing called time dilation. So Einstein supposed. So why are they doing that? Why do they do that? What is that supposed to mean? And as far as I can tell, it is only just something they made up. Einstein's gone on with the idea that the speed of light is to be constant, whatever that's supposed to mean, and by going by that he's decided to make time dilation come from that. Ideally he should be going by Newtonian physics, and you would then have variable light speed. This whole idea of introducing time dilation is just messing up the maths. So why do you do it? Is it a law of nature? No, it's not a law of nature. It's just something Einstein decided to mess the maths up with. So it is very important. It is important. He's trying to bluff it off. He's trying to bluff off what does the speed of light constant mean. Is it a law of physics? Is it a law just made up by us? Or is it a legalistic law? And they're saying it's not a law of physics. It's just something made up by us. More specifically, something made up by Einstein. There's no reason for it. You can just carry on with Newtonian physics. No need for time dilation or any other stuff that Einstein's introduced. You just carry on and use variable light speed. It's just an artificial mess to introduce this idea of a speed restriction from special relativity. So that's what we got there. So now I want to go on to Sarfati when he explains back reaction. So if we go on to this video, that's basically it from that. You say that's basically what I'm complaining about in there. That one, and I've done that bit, yeah. This one. This is a person who's a physicist, and he's fairly a maverick, and he portrays himself as a sort of coming up with these sort of radical ideas. But I don't think this is what you're going to say now is too radical, and it's sort of the thing that these people in relativity believe, or at least some of them. Some of them are saying the same sort of thing as this person's going to say now about relativity.
This is not only thinkable, it's probably going to happen. There's a good chance it's going to happen. It's going to totally change. Well, look how the internet has changed things in 20, 30 years. I mean, you ain't seen nothing yet.
I've been struggling with this past, present, and future, and I was trying to get back to that point where you said it was going to get simpler. But basically, what I did say that the thing that you said that hit me is, sorry, I'm not a scientist, but was that something was travelling faster than light. Has this, can this be?
No, but here's the thing,
So that's the relevant thing. Something's changed, moving faster than the speed of light. I think I should get this sound up a bit more. It's pretty bad. I'm trying it again.
Travelling faster than light. Has this, can this be?
No, but here's the thing, relativity says. Relativity says that an ordinary particle moving through the space-time continuum, that can't go faster than light. But space itself can. See, special relativity only talks about particles moving within the continuum, not the stretching, not the expansion of the continuum itself, the space-like part of the continuum itself. In fact, that's the whole theory of what's called inflationary cosmology. So he starts with this idea that it's that the three-dimensional spatial part of the space-time continuum, that can expand at any rate at all. It's just stuff going in it. In fact, in cosmology, the particles moving through the expanding space, that's called the peculiar velocity. The peculiar velocities of a galaxy, that cannot be faster than light, but the expansion rate itself can be. But when it is faster than light, you get this horizon effect. We can't see beyond that using light signals. But you have horizons from the future and horizons in the past. It's tricky. It's hard to grasp for one,
Just one last one.
Hard to grasp.
It seems to me, I think that possibly Aristotle final calls not final in the sense of future, but final in the sense of the sort of.
But that basically was it. It was, if I can go back to it, is this bluff of space being able to go faster than the speed of light. Go back to. So this is the. Based on that, Einstein gives you that maths. The t along here, it's the same as that one, but you've got the t0 here, which is going to be different, and you're going to have time dilation. Why do that? Why do that when you could have it still as per Newtonian physics, but you've got c along there as v, and the speed along there is v, and the speed here is that. That's just Newtonian physics. Rather than mess it up by doing that, there is no reason for doing that. There's no reason for making that mess. But they do that mess in special relativity, and it's not enough to stay with that mess. They then have to say, oh, light speed objects can go actually faster than the speed of light, and so we're going to have space itself go faster than the speed of light whenever necessary. So they make that mess, and they call that special relativity. And then special relativity, you've got the restriction, you can't go faster than the speed of light, because you've got this, see there, you're not going to get any speed faster than the speed of light there. But that's not good enough, because that's only for constant velocities. So when you've got acceleration, you've suddenly got to say, oh, the speed of light is going to be variable when there is acceleration. So suddenly you're going to have to say, well, when the speed of light is faster than that c, you've suddenly got to say, oh, it's space itself that is moving. So that's where all this bluff is coming from. If we can go back to him. So far, there we go. If we get back to the beginning where he is, where he's talking about it, if we can pick it up.
The particles moving through the expanding space, that's called the peculiar velocity. The peculiar velocity of a galaxy, that cannot be faster than light.
That can't be faster than the speed of light. So I've got that sort of set up when you can't go faster than the speed of light.
But the expansion rate itself can be. But when it is faster than light...
So the expansion rate, that is when space itself can go faster than the speed of light.
You get this horizon effect. We can't see beyond that using light signals. But you have horizons from the future and horizons in the past. It's tricky. It's hard to grasp.
Hard to grasp. So that is basically it. Having made that mess, and calling it special relativity, they then have to still make the speed of light variable. You can still make speeds faster than the speed of light c. So that speed restriction gets blown away. And go back to it. You can so this stupid idea is all bluff about it does not matter very much whether it is a law of physics, a law made up by us, i.e. Einstein, or a legalistic law. It's all bluff. It's all there in this Susskind thing. It's all just bluff, and all of it's just bluff. And you've got the problem, say, if you are treating the speed of light as being like light speed, then why are you not having exactly the same equations used in both? So this whole thought experiment by Susskind is very bogus, hence why it's just nonsense. Basically, you've gone from Einstein and you've just built more nonsense on top of it. It is the farce of Einstein's physics. Susskind just adds more nonsense to what Einstein's talking about. You've got an hour and a half and it's just all going to be nonsense. He started with nonsense here. You've got his thought experiment where you're going to treat the speed of sound as being like the speed of light, and it's just nonsense. You just don't get anything useful out of this. Treating these fish as being restricted to speeds less than the speed of sound moving around in water, and treating this whirlpool in the sea as being like a black hole is just nonsense. It just doesn't give you any useful physics whatsoever. It's just nonsense, completely nutter, built upon nonsense. Thank you.